kinetics. This branch is also important in chemistry. The chemical kinetics, the meaning, it is a study on the rate of chemical reaction. What is meant by rate of chemical reaction? The rate at which the reaction is taking place. The rate at which reactant molecules are changed into some product molecules. The rate means here the amount of conversion, chemical conversion, we specify either in terms of molecules or number of molecules or the amount of substance. Number of molecules, amount of substance. The unit of amount of substance is mole, which is a chemist unit. There is a difference between number of molecules and amount. What is the difference? The literature says 1 mole is a chemist unit, represent the amount of substance. 1 mole of substance consists of 1 Avogadro number of molecules. 1 Avogadro number, what is the number? Very big number, 6.022 into 10 to the power of 23. 10 to the power of 23, 23 zeros you have to put. If you see 26 zeros, is there any mathematical terms to see that the magnitude of the number? Highly impossible. It is, I say, billions, billions, billions. I say trillions, trillions as well. Just imagine that 1 mole of water contains 1 Avogadro number of molecules. What are those molecules? H2O molecules. H2O, H2O, H2O. 1 Avogadro number of molecules. In terms of weight, 1 mole weighs 18 grams. That is 1 mole equal to 18 grams. That 18 grams consists of 1 Avogadro number of molecules. Just imagine what would be the size of the molecule. Here the molecular size, if you take one small tiny droplet of water, it contains billions of billions of billions of water molecules. Unimaginable. That small is the molecular size. The molecular size, whether small or big, it is at nanoscale. The molecule which you cannot see by microscope, electron you can see only by electron microscope. That is the size of the molecule. So it is not possible to assess the change in terms of molecules. That is, I say billions of molecules. That you should not talk about it. That is why we use a chemical unit, that is a mole. What mole react to give what mole of product. And also there is mole means the substance always spread in space. Any substance, if you see or if you make a study with a chemical reaction, it is always spread in the space. Certain volume it is occupied. That is important. That is, amount by volume is called as concentration. That concentration term is used in this. What concentration is reacted in the given time? What concentration of one particular reactant reacted to give that product? Concentration means your molar concentration is a SI unit, concentration chemistry. Very important concentration term is molarity. How many moles are present in 1 liter, 1 dm cube? in 1 dm cube of volume, that is whether it is gaseous phase or liquid phase or solid phase, in 1 liter how many moles present? Whether 1 mole or half a mole or 0.1 mole or 2 moles, that gives a concentration, molarity. So many moles per liter is called molarity. 0.1 molar means 0.1 mole present in 1 liter. 0.5 molar, 0.5 mole, half a mole present in 1 liter. So the concentration terms. So we speak always the amount of reaction in terms of concentration of the reactants and concentration of the product. Molarity is the concentration. That is the specific term we use to express what is that chemical rate of chemical change. Now there is one chemical equation written here, a symbol that symbolizes a chemical equation. It is also called as stoichiometric chemical equation. Here what is it called? Stoichiometric chemical equation. What does it mean? For a chemical reaction to take place, there are always some minimum number of reactant molecules. Minimum number of reactant molecules come closer to each other for a collision, approach each other. Unless they approach each other, no reaction take place. Approach each other and energized and take part in chemical change. Chemical change, as you know, breaking of some chemical bonds and formation of new chemical bonds. Those chemical bonds are present in molecules. Those molecules come closer for a chemical change. How many molecules? That is, what is the number of molecules required to come closer for a step of reaction to take place? That is minimum. I say that they are called as, that is called those molecules. No, written over here. This is the number of molecules, step of reaction. So these numbers. So with these numbers, when you balance it, it is called as stoichiometric chemical equation. Balancing not the number of molecules, you are balancing the atoms involved in the reaction. All molecules made up of different atoms, of course. So these balancing, that is numerical values, balances only what number of atoms are present this side and what number of atoms, different atoms present in this side. That is equalized. Accordingly, these values are, that is called, it is balanced chemical equation or stoichiometric chemical equation. To understand clearly, I will take one typical example like this. Chemical reaction is oxidation of carbon monoxide gives carbon dioxide. Carbon monoxide is a gas, oxygen is a gas, carbon dioxide is gas. It is a gas phase reaction. In this chemical equation, this is stoichiometric chemical equation. That means two molecules of carbon monoxide combined with one molecule of oxygen gives two molecules of carbon dioxide, a step of reaction like this. Or in terms of the amount, 2 moles of carbon monoxide react with 1 mole of oxygen, give 2 moles of carbon dioxide. That way also you can speak. Or 2 molar concentration react with 1 molar concentration of oxygen to give 2 molar concentration of carbon dioxide. That is in terms of concentration. I said some minimum number of reactant molecules should come closer to each other. Here, how many molecules of carbon monoxide, oxygen come closer? Carbon monoxide structure is this: carbon with double bond oxygen, carbon with double bond oxygen. Of course, the carbon is not completely satisfied chemically. Only 2 chemical bonds here. It has a tendency to form 4 chemical bonds. That is the molecule structure. 2 molecules of carbon monoxide, 1 molecule of oxygen. The structure of oxygen is chemical bonds, oxygen, 2 chemical bonds in between them. These number of molecules should come closer. Unless these molecules come closer and approach collision and with sufficient energy, chemical reaction does not take place. So during the chemical change, when they come across, when they come close enough, very much closer to form a new chemical bond, and with sufficient energy, there is breaking of some chemical bonds. Here, these two chemical bond breaks, not these two. With the breaking of these chemical bonds, these two atoms are separated. Now, this atom has a tendency to form chemical bond with one of these molecules like this. The same two bonds here with carbon, other with other carbon monoxide. The same two bonds with other carbon monoxide. Look here, carbon dioxide structure. Carbon valence is completely silent. That is why it is highly reactive. Carbon dioxide can react with oxygen easily, forming a carbon dioxide stable molecule like this. This is the kind of reaction. Now here, breaking of chemical bonds. That is, these chemical bonds break between one bond, forming new chemical bond. That is called as chemical change. Molecules change. Carbon monoxide, oxygen changing into carbon dioxide molecules. Here balancing means what? Balance the number of atoms, elements on either side. Balance means carbon atoms here, how many? Here, carbon atoms, 2 carbon atoms. That is balancing like this, 2 carbon atoms. And balance the oxygen atoms on the other side. 2 into 2, here 2, 2 plus 2, 4, and 2 into 2, 4. Keeping in mind balancing of carbon atoms, the equation is balanced. That is called as stoichiometric chemical equation. So in this stoichiometry, two molecules of carbon monoxide react with one molecule of oxygen, gives 2 molecules of carbon dioxide. So that is called as stoichiometric chemical equation. So with this stoichiometric, we can write this stoichiometric chemical equation if we know what reactant molecules are involved, what product molecules are involved. You can balance it like this. That gives stoichiometric chemical equation, theoretical equation. And under this I have written one more equation, R is equal to K into A to the power of X into B to the power of I. Very important equation. That is an experimental rate equation. This R stands for rate of reaction. That is, at what rate the reaction is changing. What rate is reaction is proceeding, that is changing this into this, this into this with the time, that is rate of reaction. The average reaction is will deal with in later rate of reaction definition later classes. A lot of things to be discussed. That a rate of reaction always proportional to concentration of these two. If there are two molecules like that, these two okay. And equals means rate constant. That is rate of reaction, rate constant of the reaction, proportionality constant. And concentration raised to the power of exponent, concentration raised to the power of. This is not always 1. Doesn't mean there's always 1. Because it depends on the values, depends on the nature of the reactant. There is a kind of chemical reaction that is taking place. So these values, exponential values, may be 1, 2, 3, 0 fraction. That is rate of reaction depends on concentration raised to the power of what? This concentration and rate, how they are related. The rate of reaction and the concentration, how they are related. This represents how the concentration of this related with the rate, that is exponential term. These values, numerical values, you are finding by experiment. By carrying out experiment on the reaction is, so that is experiment where experimental setup is there. You can have experimental equipments. So different equipments for different experiments, that is possible to find out at what rate reaction proceed with change in concentration like this. Change in concentration, change of rate. That gives change in concentration, change of rate. What rate, what concentration. Upon that we can find out the values of these. They are called experimental values. Experimentally found values X and Y. You cannot write it by any theoretical concept. So rate of reaction is equal to rate constant of this reaction. Concentration, that is called as concentration of A, concentration of B, like this. And one important terminology in chemical kinetics is molecularity of reaction. What is molecularity of reaction? That is from the stoichiometric equation. A plus B, that is balanced equation. Number of moles of A, number of moles of B taking place. That is A plus B gives molecularity of reaction. Maybe one molecule or two molecules or three molecules or four molecules. If one molecule is involved, it is called unimolecular reaction. Two molecules, bimolecular reaction. Three molecules, third molecular reaction like this. Can classify the molecularity of reaction. And x plus y is equal to n. It is called order of the reaction. Very important term. Molecularity order. Very important. Order of the reaction. That is this plus this. What is the order of the reaction? This explains the entire mechanism of reaction. This order of reaction. What is x stands for? Your order of the reaction with respect to A. What is y? Order of the reaction with respect to B. X plus y means overall order of the reaction. There are terminologies. That is order of reaction. And one thing we have observed in all the reaction that is very important, this point and this point. That is these 2 points. Look at this stoichiometric equation, experimental rate equation, and comparison. If A equals B, this value is equal to this, and this value equals this, then the reaction, what is written here with balancing, is a simple reaction. The reaction takes place in one single, there is one step like this. In one step, reaction takes place. No other steps. Because some reactions take place in multi steps. Same reactant, same product. That is, in one step, reaction is over. Simple step, that is called a simple reaction, if that is the case. If A not equals to A, that is not equals to X, B not equals to R, or both, then the reaction is not simple, it is a complex reaction. This same step of reaction, that is stoichiometric equation, the reaction takes place, that is that in multi steps. So the reaction occurs in 2 steps, intermediate formation, neither initial nor product. There is one more step, that is intermediates form and disappear. So that is called multi steps. In multi level, the reaction takes place. That is called as complex. That is, we come to know what is that complex reaction details and simple reaction detail. So that is, reaction is called as complex reaction. This is called as. So there is a difference between order and molecularity. Order and molecularity may not be same. It is same, it is only simple reaction. So let us see that some examples of the reactions you have taken here. Examples here, one reaction between ammonium nitrite. Ammonium nitrite, it is decomposed, chemically decomposed, one molecule, 1 mole decomposed gives 1 mole of nitrogen, 2 moles of water. Of course, it becomes, now it is heated, now it becomes gaseous state, then solid. Solid, upon heating becomes gas, and then afterwards liquefied. That is decomposition of ammonium nitrite gives this unimolecular reaction. Molecularity is 1, that is reactant is 1 here, coefficient is 1. When you observe the rate of reaction is equal to rate constant of this reaction into concentration of only one reactant to the power 1. This power is 1. So order of this reaction is 1. The first order, unimolecular reaction. Here order and molecularity are same. This reaction takes place in one step, elementary step. No other steps. Simple reaction. Let us go for one more chemical reaction. H2 plus I2, well known, gives 2HI. Combination of hydrogen element, hydrogen element gives compound HI. Both of course gaseous state. Gas. In the gaseous state, because the reactions we can see are take place in gas, that is in gaseous state, gas phase, or liquid phase, solution, homogeneous solution, or in solid phase, or sometimes heterogeneous, solid liquid mix, like that also the heterogeneous reaction. They are homogeneous reaction. In only entire reaction take all molecules reactants are gases, and the reaction is also gas phase reaction, homogeneous. It is stoichiometric equation, coefficient is 1, molecularity is 1 plus 1, 2. when you determine the rate of this reaction is equal to K into hydrogen concentration to the power of 1, iodine concentration to the power of 1. 1 plus 1, order of reaction, order of this reaction with respect to hydrogen is 1, order of the reaction with respect to iodine is 1. 1 plus 1 is equal to 2, order is 2. Molecularity is 2, order is 2. Therefore, simple reaction. Reaction takes place in one simple site. This breaks and forming new chemical bond, Hi2 molecules. Look at this. Another reaction. 2NO plus O2 gives us to 2NO2. It is from this document, from this equation, we can write what is the molecularity of the reaction. 2 plus 1 equals 3. And rate of reaction is going to be K to the power of 1 to the power. Same as this. But order equals 3. This is reaction order is 3, molecularity is 3. Just like simple reaction, but somehow it is a pseudo reaction, that is complex reaction, that is not good. Let's behave like a simple reaction. That is, we will not have to discuss more. So, third molecular reaction and order is 3. Third order reaction, molecularity is 2. First order, second order, third order. Unimolecular, bimolecular, termolecular. What is termolecular? 3 molecules are involved. Let us go to the next one, next set of examples. Look at that, is a decomposition of nitrogen dioxide. Dinitrogen, that is nitrogen pentoxide. Nitrogen pentoxide. Of course, what is that? Is what is that? Solid at room temperature. When it is decomposed now, so it immediately becomes gas and gas. Gaseous state, of course. Nitrogen pentoxide. This is the stoichiometric chemical equation. He says that it is a bimolecular reaction. 2 molecules of the same reactant, of course. Bimolecular reaction. But the experiment says that what is the experimental determination of rate of reaction in terms of concentration of this, it is going to be to the power of 1. Order of reaction is 1. Yes, molecularity order is different. If that is the case, the reaction is complex reaction, not simple. This is also called as pseudo reaction. What the equation? No, let us check. This is false. That is same reaction but occurs in 2 or 3 steps. That is called false pseudo reaction. What is the mechanism proposed on the basis of this order molecularity? With pen and paper and all this now, with all these experimental evidences, it is shown that nitrogen dioxide first decomposed into, not directly into this, NO2 plus NO3. NO2 is okay, but NO3 is not the product. It is an intermediate. It will never stay. It will undergo reaction again immediately, highly reactive intermediate. This intermediate react with another reacting molecules. One more step. Then becomes nitrogen dioxide, that is NO2 again, this one NO2 plus 2. So overall 3 plus 1, 4. This oxygen. This form and disappear, cancel, intermediate. This is neither initial nor final, it is an intermediate, cancel. Therefore, net reaction is this. So in these 2 steps of reaction, this slow, it is a slow. This reaction proceeds, it is very slow. Compare now, the rate of reaction will be different for multi-reaction. There are 2 steps or 3 steps. That is faster, this is slow. The rate of entire reaction depends on this. Because one step is slow, other steps are fast. Unless this step occurs, the other step will wait for that. That is why rate of the entire, that is the rate or velocity of the entire reaction depends on the rate of this step, slow step. It is called rate determining step. That is in complex reaction. Visualize this, the rate determining step. It is called as rate determining step in this complex reaction. So similarly we have one more chemical equation, that is NO plus H2, that is nitric oxide plus hydrogen gives rise to nitrogen and water. All are gaseous state, vapor. Gas phase reaction. Molecularity is equal to 4, 2 plus 2. Order when you form the experiment, rate of reaction, that is concentration to the power of 2, and concentration by 2 to the power of 1, not 2, that is order equals 3. So order is 3, modified is pseudo order again, pseudo reaction. What is the mechanism is proposed on the basis of all experimental evidence and this experiment. This is a proposed. NO plus S2 gives us to N2 plus H2O2. Look here, N2 is okay. What is that reaction? N2 is a product. But this is hydrogen peroxide. It is an intermediate reactive, neither initial nor fast. So this intermediate react with one more hydrogen molecule. Immediately what is now? Forming water. This reaction is faster. This reaction is slow. The rate of this reaction is depending on the rate of this reaction. It is a rate determining step. Intermediate formation is hydrogen peroxide. Cancel. This gives us to this. That is a complex reaction. This reaction occurs in multi-steps. Some reaction, no, 3 steps, most of in organic chemistry, sometimes 4 steps, 5 steps reactions. There are solo reactions. That is. One more example is this: nitrogen dioxide, carbon monoxide, NO plus carbon dioxide. Look at this, molecularity is 1 plus 1, 2. Rate of reaction is found to be K. That is concentration to the power of 2, concentration to the power of 0. But is order molecule is same, but the order of reaction with respect to carbon monoxide is 0. I said 0 is also possible. 0 is also possible value in this order. 0, fraction, negative, positive like this. 0. Therefore, anything to the power of 0 is 1. That is, our rate of reaction is equal to K into NO2 concentration to the power of 0. Second order, but is pseudo. Not 1 into, it is not like this. This is 1, this is 1, it is not. It is 2, it is 1. The complex reaction mechanism. Here, this is the one mechanism we have proposed. NO2 plus NO2. 2 molecules first involved, combined. That is, collide each other, forming NO plus NO3. That is again intermediate for unstable. This intermediate can react with the other reactant molecule, forming carbon dioxide and NO2. This is faster reaction, this is slower reaction. This is rate determining step of this reaction. So this is mechanism is proposed. So these are called as pseudo reactions, false reaction. They will not occur in one step like this. They will occur in multi steps. That is, we have found by looking at the difference in molecularity and order of reaction. So we need to understand, that is I just explained only what is meant by molecularity and order, taking these 2 equations. This equation is theoretical equation, this is experimental equation. Let us go in detail about the rate of lot of things we learn. Kinetics. Proceed in the next class. The importance of this equation and how you can study the chemical kinetics, the rate and the order.